Here we have a problem on finding derivative. So we have y equals to sin x or cosine x. We have to find dy over dx. That is, we have to find the derivative of this function with respect to x. Okay, in the given function, we have variable in both numerator and denominator. Okay, so if I want to find derivative of a function which contains variable in both numerator and denominator, I have to use coefficient rule. What is coefficient rule? Okay, let's consider the function in the form u over v. So let's assume both u and v are variables, and if I want to find derivative of this one, I have to use coefficient rule. The coefficient rule is, so whatever stuff I have in denominator, that has to be squared over here, and the same stuff, I mean the denominator, same denominator v should be taken over here, and get the derivative of u, that is u prime. Now take negative sign. Now we have to take the numerator part u as it is, and get the derivative of the denominator v, that is v prime. So this is coefficient rule. Okay, now let's apply coefficient rule to get derivative of the given function over here, because it contains variable in both numerator and denominator. Okay, here when I find derivative of this y with respect to x, it will just become dy over dx. On the right side, we have to take the square of the denominator. So here we have cosine x. When I take square of this denominator cosine x, it will be cosine x the whole square. And here the same cosine x should be taken at the top, and now I have to get the derivative of the numerator sin x, so that is sin x prime. Now I have to take negative sign. Now I have to take the numerator part sin x as it is, and get the derivative of the denominator part, which is cosine x, so cosine x prime. Okay, so we get dy over dx equals to cosine x times, so the derivative of this sin x with respect to x is just cosine x negative sin x times the derivative of cosine x with respect to x is negative sin x over, so cosine x whole square can be written as cosine square x. Okay, so we get dy over dx equals to cosine x times cosine x will become cosine square x, and here negative times negative will become positive, sin x times sin x will become sin square x over cosine square x. Okay, according to Pythagorean identity, so the value of cosine square x positive sin square x is just 1. So we can write 1 over cosine square x. Okay, so here dy over dx equals to. Okay, so we can use a reciprocal trigonometric identity over here. So that is if I have 1 over cosine x, it can be written as secant x. Then what can we write for 1 over cosine square x? For 1 over cosine x, we write secant x. For 1 over cosine square x, we can write secant square x. So the derivative of the given function is secant square x.